All right, when we talk about probability, it turns out that not all events are, created equal. Some can happen at the same time, while others, no way. Some have this domino effect on each other, and some are basically complete strangers. So today, we're going to break down the 4 types of events that you absolutely have to know, especially if you're even thinking about getting into data science.
Okay, so everything really kicks off with one simple question, and this is what separates our first 2 types of events. And the question is this: can 2 things happen at the exact same time? And believe it or not, your answer to that question sends us down 2 totally different paths.
And that question right there brings us to our very first pair of event types. It's all about one single idea: the possibility of overlap.
So first up, we've got what are called joint events. Basically, these are any events where there's a chance for them to overlap, for them to happen at the same time. You can think of it like 2 things that share some common ground, and that's why you'll also hear them called non-mutually exclusive, because they don't exclude each other.
And honestly, the best way to picture this is with a good old Venn diagram, right? Imagine each of those circles is an event. Well, that little bit that overlaps in the middle, that's the sweet spot. That's the shared outcome, the thing that links both of these events together.
Now, on the flip side of that coin, we have disjoint events. And these are, well, the complete opposite. They are mutually exclusive, which is just a fancy way of saying if one of them happens, the other one absolutely positively cannot happen at the same time. They have 0, and I mean 0, outcomes in common.
And yeah, the visual for this is just as straightforward. You've got 2 separate circles that don't even touch. There's no overlap, no intersection, because there's nothing to share. It is a totally clean break.
Okay, so let's just put them side by side for a second. Joint events, they can happen together because they share something. Disjoint events, nope, they are totally separate with absolutely no overlap whatsoever.
Now, this distinction becomes absolutely crucial when you start calculating the probability of A or B happening. See, for disjoint events, it's super easy. You just add their probabilities together. But for joint events, you got to be careful. If you just add them, you've actually counted that overlapping part twice. That's why the formula has you subtract that overlap once to get the right answer.
Okay, let's make this real with a quick example. Imagine you roll a standard 6-sided die. So event A is getting an even number, that's 2, 4, or 6. Event B is getting a prime number, that's 2, 3, or 5. Are these disjoint? You bet they are. Why? Because of the number 2. It's both even and prime, so it's that common outcome that lives in both sets.
All right, so that's our first pair down. Now let's move to our next set of events and see how this all builds. We're going to shift our focus away from overlap and onto a brand new question: influence. Do these events actually have any effect on each other?
And this is really the core question for our next 2 event types. Does the outcome of one event actually affect the outcome of another one? What we're really looking for is there a chain reaction here, or are we just looking at 2 totally separate things happening? First up, we've got dependent events. And just like the name says, these things are linked. Whatever happens in that first event directly changes the entire setup, and therefore the probability for the second one. The classic example for this is drawing cards from a deck, but without putting them back. So let's say your first event is drawing a red card. Okay, the probability for that is 26 out of 52. But now you don't put it back. The deck has physically changed. You're now holding a deck with only 51 cards. So the probability of whatever you draw next has completely shifted. Event A has directly influenced the odds for event B. And then you've got the other kind, independent events. And yeah, the name says it all. These are completely separate. The outcome of one event has absolutely 0, zilch, no impact on the outcome of another. You want to know the perfect example of this? Tossing a coin. Seriously, if you flip a coin and get heads, what are the odds of getting tails on the next flip? Still 50-50, right? The coin doesn't have a memory. It doesn't care what happened last time. That makes these events totally independent.
So the big takeaway here really is that one word, influence. And this completely changes how you calculate the probability of both A and B happening. For independent events, it's a piece of cake. You just multiply their probabilities together. But for dependent events, you have to account for that first event's impact. So you multiply the probability of A by the new probability of B, given that A already happened.
Okay, that's enough theory for now. Let's actually put this stuff into practice with a couple of quick card drawing examples just to make sure it's all clicking.
All right, first challenge. You draw one card from a standard 52-card deck. What is the probability that it's a king or a queen? Now, before you do any math, you have to ask yourself that first question. Are these events joint or are they disjoint? The answer? They're disjoint. Think about it. A single card can't be both a king and a queen at the same time. There's just no overlap. And because of that, our calculation is easy. We just add their individual probabilities. So that's the 4 out of 52 chance of getting a king, plus the 4 out of 52 chance for a queen.
Okay, ready for another one? Second challenge. Same deal, you draw one card. But this time, what's the probability that it's red or a face card? And just to be clear, a face card is a jack, queen, or king.
Aha, now this time we definitely have an overlap, don't we? A card can absolutely be both red and a face card. I'm thinking of the King of Hearts, the Jack of Diamonds. In fact, there are 6 cards like that. So that makes this a joint event, which means we have to pull out that special formula and remember to subtract that 6-card overlap so we don't accidentally count those cards twice.
So we've covered all this theory, we've done some examples, but you might be thinking, why does any of this actually matter once you're outside of a math class?
Well, let me tell you, this is not just some abstract theory. These are the foundational building blocks for huge fields like data science. And this stuff comes up all the time in technical interviews. So understanding the difference isn't just for a test, it's a real practical career-building skill.
And that leaves us with one final thought I want you to take away from this. Start looking for these ideas in your own life. Is your decision to grab an umbrella truly independent of the weather forecast? Of course not. Is the success of your morning commute dependent on what time you leave the house? You bet it is. Once you start looking for it, you're going to see that this stuff, this probability, it is absolutely everywhere.